Alright, welcome. In this video, I'm going to be working Algebra 2 Homework 7.1. So this is going to be, a lot of complex number arithmetic. And so we're going to start with a little bit of like, hey, simplify this number, write this number in terms of I. Okay, so 8 times the square root of negative 4 would be 8 times the square root of 4 times the square root of negative 1. And we're calling the square root of negative 1 I now. So that's 8 times 2 times I, so that's going to be 16I. 6 times the square root of negative 12. I'm just going to start to break down the square root of negative 12, but negative 12 isn't a perfect square, so I'm trying to think what is a factor of it that is a perfect square, and that would be 4. So I'm going to do 4 times 3, and then I've still got that negativity, so I'm going to hold that off to last and say, okay, times the square root of negative 1, which we're going to call I. So it's going to be 6 times 2 times the square root of 3 times I, which is going to be 12 root 3I. And then 1/3 root negative 90. Okay, what I see that's a factor of negative 90 immediately is 9, and I know that's a square number, so I think that's all I can do. So it's going to be 1/3 of the square root of 9 times the square root of 10 times the square root of negative 1. So I'll get 1/3 of 3 times root 10 times I. So that'll be just square root of 10 times I. Okay. These next ones want us to find the values of x that make the equation true, so we're just going to kind of directly solve at these. So I'm going to say, all right, x squared equals negative 49. Take the square root of both sides. Don't forget the plus minus. Okay, I can rewrite negative 49 square root as the square root of 49 times the square root of negative 1, and that's going to be plus or minus 7i. 3x squared plus 27, very much the same, so 3x squared equals negative 27, x squared equals negative 9. X is going to be plus or minus the square root of negative 9, which I'm going to call square root of 9 times the square root of negative 1. That's going to be plus or minus 3i. And then 2x plus 12.5 equals 0. Okay. Alright, well, I think you got a couple of options here. Either way, I'm just going to say 2x squared equals negative 12.5, and then I'm going to divide both sides by 2, not multiply both sides by 2. So I'd have x squared is equal to negative 6.25. Now, if you happen to know, what that decimal number is, good for you. You probably also know what the square root of that decimal number is. But what I'm going to do is I'm going to kind of backtrack a little bit and say negative 12.5, that's negative 25 divided by 2. So if I divided both sides by 2, that's like multiplying by a half, that's going to be negative 25 divided by 4. And this will be much easier to solve because I don't just know the square root of that. I guess I could probably figure out that it's 1.25, but it takes a little bit. Or maybe not even. I don't even know. Maybe it's 2.5. Yeah, I think it's more like 2.5. Yeah, I'm going to get 5 halves. So it's the square root of 25 over 4. Well, I guess the negative. Let me try that one more time. Yeah, that's better. And then I can rewrite that as plus or minus square root 25 divided by square root of 4 times the square root of negative 1. And so that would be plus or minus 5 divided by 2 i's. Alright, now these next three, find the zeros of the function. Well, zeros is just set the thing equal to 0 and solve for x. It's going to be a lot like what we've been doing already. So 5x squared plus 15 equals 0. Negative 15 over 5, which is negative 3. If I take the square root of both sides, okay, that would give me just x. Plus or minus the square root of negative 3, which is going to be square root of 3 times square root of negative 1. So I've got plus or minus root 3 i's. With number 8, same thing coming. I've got 3x squared plus 21 equaling 0. Okay, x squared equaling negative 7. Take the square root of both sides. Don't forget that plus minus. So this is plus or minus root 7 i's. And then the last one, okay, that'll be interesting. So negative 1/4 x squared minus 13 is equal to 0. If I'm trying to find the zeros of the function, say g of x equals 0. And just start solving x squared. Add 13 to both sides, maybe multiply by negative 4. 13 times negative 4 will be negative 52. But maybe I shouldn't write it as negative 52. Maybe I write it as negative 13 times 4. Okay, so that when I take the square root of both sides, I can say square root of negative 13 times 4, and I'm just going to split it up like that. I was going to do it anyway, so might as well not put them together if I'm going to take them apart eventually anyway. So x equaling plus or minus the square root of 4, square root of 13, and the square root of negative 1. So that's plus or minus 2 root 13i. Alright, so I think that's probably enough directly solving equations. There might be some quadratic formula coming our way in a minute. Well, not for a while, at least, it looks like. Plot each number on the complex plane. All right, a equals 3. So 3 is a real number, so it's just right there on the real number line. Okay, b equals 2i. 2i is a purely imaginary number, so it's going to just be on that imaginary axis. Negative 1 plus 4i. Okay, so it's basically at the coordinates negative 1 and 4. I'll call that c. d is 5 minus 2i. And e is 3 plus 3i. Okay, so that's how we're going to plot these numbers. Hopefully that's a problem you look at and see, okay, that's one of the easy ones. I'm going to definitely get that one right. Okay, if the given x value is a root of a quadratic polynomial, what is the other root? Okay, so I feel like I may have slipped these problems into the homework one lesson too early. Okay, we don't really know about the complex conjugates theorem. We're going to see that complex roots of polynomials come in conjugate pairs, but I guess if we were going to have an imaginary root of a quadratic equation, that would be because, b squared minus 4ac came back negative when we were doing the quadratic formula. And we can see that if, it's the square root that's causing the I. So I don't know, I'm not going to waste too much time on this. I'm just going to say, all right, x equals negative 1 minus 4i, and x equals negative 12 plus 1i. Those are also going to be, that's going to be the other root if we've got those given roots of a quadratic polynomial. Okay, now let's do some arithmetic. So add or subtract, write the answer in the standard form. All right, we can do this. So 4 plus I plus negative 3i, we're just going to kind of subtract the i's right there, and that's going to be 4 minus 2i, and that is standard form. Okay. Negative 3 minus 3i minus, okay, so I need to distribute the negative to the 4 and the 3i. And then I'm going to need to kind of combine like terms, so I'll have negative 3 minus 4 and negative 3i minus 3 more I, and that's standard form. Distribute the negative. Okay, so 6 minus 4 is 2, negative 5i. There's not really anything to do with that. We'll just leave it as it is, and there we go. We got it in standard form. All right. Square root of negative 25. I think I've done this enough times in the examples in the video and on the homework and stuff that I think I'm going to be able to just call this 5i. I hope that's right. Minus, okay, going to call that 3i. And the square root of negative 81, that's going to be plus 9i. And the minus and plus are just, I'm just copying this one and that one. Nothing special about those. Okay, so I'm going to combine my like terms. 5 minus 3 is 2, 2 plus 9 is 11i. And, if we just had to write it as a plus bi, we'd write it like that. If you didn't give me a 0, I would still count that as standard form. I don't think you need to be writing redundant zeros. That's not what we're about. So, all right, we're going to go over here. We're going to distribute a negative. So minus 17 plus 7i plus 8i. 14 minus 17 is negative 3. 7 and 8 would be positive 15i. And the last one of these is like addition and subtraction ones. So plus is just, add like we expect. Negative 4 plus 9 is going to be 5 plus 1i. Okay, and that's some addition and subtraction. That's good. We need to practice that. Alright, now I can do some multiplication. Now, I think at this point, having done, 21 problems already? 22 already. There's two number 22s. Alright, having done this many, I just want to remind you that, if you're just kind of like watching along, following along with me, that's decent. That's fine. But the best course of action for you to just like really learn this or whatever you're trying to learn in my class is going to be for you to try the homework on your own first and then check your answers against it. Like I always say, and I know it's not what you want to do, but it's what you need to hear right now. So if you have not tried numbers 22, 23, and 24, I would really like for you to try them on your own right now before watching me do it, right? Because that's going to be the best way for you to learn. So without further ado, here I go. I'm going to do it. So if I go and I multiply these, I just use the distributive property. There we go. So negative 12i times negative 1 will be positive 12i, and negative 12i times positive 4i would be minus 48 times I squared. Okay, we know that I squared means negative 1, so 12i minus 48 times negative 1 will be positive 48. Okay, so 48 plus 12i. With the next one, I'm going to have to, pretty much do FOIL, so 3 times 2 is 3 times 9i. Negative 5i times 2. And negative 5i times 9i would be negative 45i to the 2. Same story here. Go collect that I to the 2 term and say, all right, that's 6 plus 45 now, because negative 45 times that yellow I squared, that's going to be negative 45 times negative 1, which would be positive 45. And then plus 27i and minus 10i would be 17, so 6 and 45, that's 51 plus 17i. That'll be far enough. Okay, 5 plus 6i squared. Okay, you just got to be careful with this one. We need to actually multiply it out twice. Don't fall into the trap of saying that this is 25 minus 36 or something like that. That's not going to work. So what we're going to do is we're going to first, I'm feeling like I don't really have enough room. Maybe I'll just zoom in on this one only. Yeah, that'd be good. So I'm actually going to multiply this out. 5 plus 6i times 5 plus 6i. And then I'm going to distribute, so 5 times 5, 5 times 6i. The other 6i times 5 will also be 30i's, and then 6i times 6i, it's going to be positive 36i to the 2. Make that substitution there. Let's say this is 25 minus 36 plus 60i's. Okay, so 25 minus 36, that's going to be negative 11 plus 60i, and that's standard form. Now we're going to do a little bit of division. Alright, and, alright, this one's going a little faster than I expected. I thought this was going to take a really long time. I guess, it's just arithmetic. So, with division, what we do is we're always going to multiply on top and bottom by the conjugate of the denominator. Alright, so that's going to look like multiplying by positive 4i would be negative 4i. Now, with these where there's no real term, you could divide or multiply on top and on bottom by positive 4i. I kind of like this though, because this always will leave you with, if you do the conjugate, even if it's just a purely imaginary number, it'll leave you with a positive real number in the denominator, which I kind of like. Okay, so it's up to you. Okay, so I'm going to actually multiply these out, and so 8 times negative 4 would be negative 32i. Negative 12 times negative 4 is positive 48, and then there's 2 powers of I. And divided by 4i times negative 4i is negative 16i squared. So I just need to remember to deal with these here, and I'll have this equaling, alright, negative 48 from the 48i squared minus 32i divided by negative 16 times negative 1 would be positive 16. So I'll have to divide both of those numbers by 16. Negative 48 divided by 16, that's negative 3. And negative 32 divided by 16, that's negative 2. So that's how I'm going to divide those. Here with number 26, I need to multiply on top and bottom by the conjugate of the denominator. Right, so 3 times 5, 3 times negative 2i, 12i times 5, and 12i times negative 2i. Divide by on bottom, 5 times 5 is 25. I know that the outside and inside terms are going to add away to 0, negative 10i plus 10i. So I'm going to not even write those down. Negative 4i squared. So I just need to get rid of these I squareds, replace them with a negative 1. So this would be 15 plus 24 minus 6i plus 60i's divided by 25 plus 4 is 29. So it's going to be 39 plus 54i divided by 29. And honestly, I'm cool with this. This is standard form enough for me in my class, but if you just had to divide both of them, it'd be 39 over 29 plus 54 over 29i. And that would be standard form. Either one of those works for me, though, in my class. This next one looks like it's going to go down pretty nice. 1 plus I means I need to multiply on top and bottom by 1 minus I. Okay, so we're always taking the denominator, taking the complex conjugate of that, and multiplying by that over itself to kind of free up the denominator into a real number. Okay, so when I do that, I'll distribute the 2i over the 1 and the negative I in the numerator of the blue fraction. So I'll have 2i minus 2i squared. And then in the denominator, I'm going to kind of FOIL out these, and I'll have 1 times 1 minus I plus I minus I squared. I kind of lost track of what I was doing. I usually don't write out the middle terms because I know they're going to cancel off that negative I plus I. And I just kind of go and search for my I squareds, change those mentally to negative 1. So I'll have 2i minus 2 times negative 1 divided by 1 minus negative 1. So that's going to be 2 plus 2i divided by 2. That's just going to be 1 plus I. All right, that's unexpected that 2i divided by 1 plus I equals 1 plus I. Wait a second. Is that right? No, that is right. That's just kind of an oddity of complex arithmetic. So I'm just going to move on. I'm not thinking anymore about that. 1 plus I squared divided by 3. Okay, so I just need to actually do 1 plus I times 1 plus I, which is again getting at what I just realized when I was looking at this with the video pause, that if you square this, you're going to get 1 times 1 plus 1 times I plus another 1 times I plus I times I, which I think I'm just going to go ahead and call negative 1. I squared, right? And then divide by 3. And then pretty much what happens is the 1 and the negative 1 are going to add to 0, and so I just get 2i divided by 3. And that sounds unexpected. That's just some sort of oddity of complex arithmetic, like I said earlier. All right, now we're going to plot the complex number and find the absolute value of the number. And we're going to give our answers in simplest radical form. I think I meant to say simplified radical form, but it's all right. So I'm going to go over here, 3 minus 4i. So maybe I'll say that's 3, and this is negative 4i. Okay. If I wanted to find the absolute value of that number, it's really like, I don't know if I said it before, but it's the distance from 0, just like the absolute value of a number. Okay, so I could turn this into a triangle that had side lengths of 3 and 4. It's a right triangle, and we know about 3, 4, 5 from geometry class. We could also say the absolute value of 3 minus 4i is equal to the square root of 3 squared is 9 plus negative 4 squared is positive 16, and that's the square root of 25, which is 5. 1 plus 6i right here, that's another thing that we could turn into a triangle, or we could just use the formula. Doesn't matter, just however you're looking at it. So the absolute value of 1 plus 6i is going to be the square root of 1 squared plus 6 squared, which is going to be the square root of 3637. Okay. And the last one is negative 5 plus 12i. Okay, so here that's back here. And this distance from 0, okay, again, the length of the hypotenuse of that triangle. This is a 5, 12 triangle, and that's one that you need to know for the SAT and stuff. It's 5, 12, 13. Okay, so I'm just going to say that the absolute value of negative 5 plus 12i, if you know your special right triangles, I guess your Pythagorean triples, not your special right triangles, and that's going to be 13 because of the 5, 12, 13 triple. Right, with these, we're going to find the value by kind of going to a nearby power of I that's like multiple of 4, and then kind of going from there. Because we know the key fact here is that I to the 4 equals 1. That's the big one. Now you can do I squared equals negative 1 and go from there, but that's just kind of going to take longer. So I'm going to say, all right, I to the 14. That's pretty near I to the 12, which I know is going to be equal to 1. So it's I to the 12 times I to the 2. Okay, I to the 12, I can write as I to the 4 cubed, which is 1 cubed. I squared, I know, is negative 1. Okay, so in total, I've got a product of negative 1. Because any power of positive 1 is going to be 1, and then times a negative 1. Okay, I to the 73, I think 72 is divisible by 4. Okay, but how I would test that is I would try to divide it in half twice, right? So I to the 72, I to the 36 squared, yeah, that's going to work. Okay, so it's going to be 18 times 4? I didn't know that. So 40 and 32, yeah, sure enough. So I to the 18th to the 4th, okay, that's 72 powers. Okay, last one is 73. Okay, so probably, I don't know much about I to the 18th. I want I to the 4 to the 18th power. So that's 1 to the 18th times I. That's just going to be 1i. I to the 127. All right, so I'm thinking 120 is one that I know is going to be, a multiple of 4. So I to the 120, and then I've got 7 left, and let's do 4 and 3. So I to the 120 is going to be a power of I to the 4. I to the 4 is 1. I to the 3 is I squared times I. Okay, just keep breaking it down, right? Okay, this is going to be 1 to the 30th times 1 times, that's going to be a negative 1, and that's going to be an I. Okay, so in total, I've got negative 1 times I is equal to negative I. And I to the 224, I feel like this one's going to be divisible by 4. So let's just see what happens if I divide 224 by 2. I'm going to get 112, and that's going to be 56. Yeah. Okay, so I know I can just multiply 56 by 4 to get 224. So I'm going to say that this is equal to I to the 4 to the 56th power. But we also know that I to the 4 is equal to 1. So I'm just going to get 1. All right. Number 31, I guess is this the last? Yeah, these are the last problems. We're going to find the values of x to make the equation true, and I think we're going to solve these a variety of ways. Yeah, okay, so I think we're going to solve the second and third ones directly, but I'm going to use the quadratic formula on the first one, because I can't think of two numbers that multiply to positive 5 while adding to positive 4. It seems like I should be able to, but the more you think about it, the more you realize I can't do it. All right, so we know x equals, I'll even copy it down, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in this case, it's going to be negative 4 plus or minus the square root of b squared is 16 minus 4 times a times c is b, 4 times 1 times 5, all divided by 2 times 1. Okay, but we can work with this now because this is negative 4 plus or minus the square root of negative 4 all divided by 2. Oh, whoops. Let's see, I might need a little bit more room here. Yeah, that'll be good. And that'll be negative 4 plus or minus 2i all divided by 2, which I could divide everything by 2 and say this is negative 2 plus or minus 1i. Alright, that was good. And this one in the middle, I'm just going to try to solve for this x plus 3 squared. I think we did this a little bit when we studied quadratics. So I'm going to subtract 16 from both sides, so 7 minus 16 is going to be negative 9. Okay, then I'm going to take the square root of both sides. Just don't forget the plus or minus. Okay, the square root of negative 9, I'm going to call that 3i. And I guess I could just solve for x by subtracting 3 and have negative 3 plus or minus 3i. That's nice. Then the last one here, I think I'm going to solve this one directly, just kind of get at x squared by subtracting 2. And I can do that because I don't have any like x to the first or x to the third term in here. It's just an x squared and some numbers. Divide by 6. And take the square root. Okay, so I've got the 1/3 and the negative 1 in there. Okay, so that 1/3, that's the square root of 1 on top, which is 1, divided by the square root of 3, and we haven't had reason to do this yet, so I'm not going to really penalize you if you're not super good at getting to simplified radical form with rationalizing your denominator. But what we do is we multiply by root 3 over root 3. That negative 1 would become an I, and so it would be plus or minus root 3 over 3 i's. Okay, and that's going to be all for this video. That's all the problems for the homework. Hope that was enough. Hope this helped. Thanks for watching.